I'm recording the vodcast for lab 3.3. My name is Ramsey. There's a picture of me. Yay! Okay, so I'm going to go through this fairly quickly. In one of the sides, it released heat, and one of the sides, it got kind of cold. All right. When the two sides mixed, it turned yellow and you saw bubbles. This is a sign that there is definitely a gas that was produced. Okay. Get my little pen tool. Come here, pen. Come here, pen. Right. Okay. So draw an energy diagram for what happened on the left side. Label delta H and E sub A. So on the left side, it released heat. So if it released heat, that's exothermic. So if this is energy, and this is going to be time, exothermic, you end up lower than you started. This is E sub A, and this is delta H. Now notice, delta H is the difference in energy from where you began to where you started, and that's called a state function. Irrelevant of path. I could have gone in some crazy direction, but as long as I ended up lower than I started, the reaction's exothermic, and the delta H is the difference from where you began to where you started. So that's called a state function. It's irrelevant of path, kind of like velocity. It's simply a displacement. You don't need to know that, but just some info for you to be aware of. Okay, on the right side, it got cold, so that's endo. And in an endothermic reaction, you end up higher than you started. So this is energy, and this is time. So in the endothermic reaction, we're going to end up at a higher spot. Our E sub A is still the height of the hill, and our delta H, what's going on here? Our delta H is going to be defined as the difference in energy. In this case, delta H is greater than 0, and in this case, delta H is less than 0. Okay. In which reaction, the right side or the left side, is the bond energy of the reactants greater than the products? Okay, so if delta H equals the sum of the enthalpy for the broken bonds minus the sum of the enthalpy for the formed bonds, and we can redefine that as delta H equals the sum of the reactants minus the sum of the products. For delta H, for reactants to be greater than products, that would give us a delta H that is greater than 0. So in which side was it endothermic? That would have been the right side. Okay, for me. For you guys, it might have been the left side, so be aware of that. So, right side. So again, if it's broken minus formed, broken is greater than formed, and broken are the reactants, that would be endothermic. Predict the sign on delta G. You don't need to do any calculations for this when they mixed. Delta G equals negative. The reaction happened on its own. No outside force needed. Thus, it was spontaneous. Okay, predict the sign of delta S. Delta S equals positive, okay? Gas was produced. It's a messy reaction. Okay, now they wanted the spontaneity conditions if it were exothermic or endo. So let's do exo here, and let's do endo here. So we got delta S is going to be positive in both cases. And if delta H is negative and delta H is positive, what's the difference here? In this case, it's always spontaneous. And in this case, it's spontaneous only at low temperatures. Let me double check and make sure that's correct. If delta H is positive minus T times positive, yep, nope. Nope, I'm sorry, spontaneous at high temperatures. So it's spontaneous only at high temperatures in this case. All right. The AP problem was a really good problem, and it's actually a very simple problem. Remember, we're not doing this part B. So it says 2 atoms of nitrogen. Here's a key point here. Combine to form a nitrogen molecule. Now that's key. The word form is actually given there. We do see the word bond, and they are asking us for delta H. So the equation is going to be delta H equals the sum of the broken minus the sum of the formed. Okay, so we're going to plug that in. So delta H equals sum of broken. There is nothing broken here. This is 2 nitrogen atoms. It's not a compound. So it's 0 for broken. For formed, you have N2, and we got to figure out which one of these is N2. Well, the Lewis structure for N2 is going to look like that. So it's going to be 950. So this one is going to be negative 950 kilojoules per mole. There's the units that they gave you right there in the problem. Okay, take care, everybody.